So we are moving on to Unit 2 now, which is exponential functions. And we're going to go through a couple of things. We're going to look at the general graph. We're going to have a look at how it moves, and we're going to end up by graphing it. So exponential functions look like this over here. This black bit over here is from your formula sheet. So you'll have that on all your tests and your assignments. So keep it beside you as you go. So you can see up here, we have a standard formula for exponential graphs, and we have a standard graph too. Okay? There's three main points that you'll use when you're graphing, but it's got two distinctive features here. It has a y-intercept, which we've seen many times before, and it has an asymptote, which is new this unit. We haven't seen asymptotes yet, and we'll talk a little bit about that a little bit later on. Okay, but an exponential function shows rapid growth. Okay, you've probably heard the phrase exponential growth, or it grows exponentially. That's what we're talking about. So it starts off pretty slow and then it ramps up really quickly. Okay, so it goes from kind of not doing much to accelerating very quickly. When we graph these, we'll find the asymptote, we'll find the y-intercept, and we'll also find one other point just to give us a really good look at what it's going to look like. So this is in standard form, okay? So this form here on your formula sheet, most of them will look pretty much like that. So it's got A, B, and K, and we have to have a look at what that means. So K tells us where the asymptote is. As I said, we're going to go, it's a bit complicated, so we're going to go into that separately. But pretty much it's a line here that the function doesn't touch. Okay, so that one there is a horizontal asymptote. It goes horizontally across and the graph won't touch it. Okay, A plus K tells us where the y-intercept is. Okay, same as any other function, the y-intercept, just where the graph intercepts the y-axis. And then AB plus K tells us the value of y when x equals 1. So this just gives us another point that we can really quickly find when we have to graph and we need those three things, the asymptote, the y-intercept, and one other point. Okay, so if you find the value of the function when x equals 1, it's often the quickest way to graph an exponential. Okay, so we're going to now find our y-intercept. And the easiest way to do this, I think, is to stick with our y-intercepts occur when x equals 0. Okay, you can use this little formula down here, a plus k, but it gets a bit confusing and I find a lot of students make mistakes when there's no a or there's no k. So for example, here, here, and here, there's no a and there's no k. So the first one, it works out okay. The second one, a lot of people would get that wrong if they tried to use a plus k. So for the sake of hindsight, we're just going to, in this course, look at finding the y-intercepts when x equals 0. Okay, so for the first one, the y-intercept occurs when x equals 0. I'm going to rewrite it and just sub 0 in for x. Okay, we know from our index law that anything to the power of 0 equals 1. So our y-intercept is at 1. So let's try the next one using the same technique. So the y-intercept occurs when x equals 0. Going to sub 0 in for x. Oops, just written that badly. It's a bit hard to tell there, but that's all the power. So 0 plus 2 is just 2. 3 squared is 9. Therefore, the y-intercept is at 9. Okay. And the last one. So same thing, y-intercept occurs when x equals 0. So we're subbing in wherever we see an x, we're going to put a 0. Anything to the power of 0 is 1. Y-intercept is at 4. Okay, so I find that's the easiest method to use. It's also really good because it works for linear, cubic, quadratic, exponential, logarithmic. It works the same for all of them. So if you can remember that the y-intercept occurs when x equals 0, that's half your exams done at the end of the year using the same technique. Okay, so that's the y-intercepts. So our next part we're going to look at is the asymptotes. Now these are probably the most difficult to understand part of exponentials, but you can get away with just knowing the basics, as in this is a line and the function doesn't touch it. So that's the most basic understanding. It doesn't touch the asymptote. The function will go, on my pen, the function will go down, it will go closer and closer and closer, but it will never actually touch that line of k. Okay, the more complicated version is that k is a limit, which means that the function gets infinitely closer to the limit, but it will never touch nor will it cross. So if you think about maybe like a jar, you fill it with golf balls, you will find, an approximation of the volume. If you fill it instead of golf balls with M&Ms, you will get closer to the actual volume. Okay? If you fill it with sand, you will get closer again to the actual volume, but you will never get the exact volume because there'll be space between everything, so unless you use liquid. But my point is you can get closer and closer and closer without touching it. So one value here might be, let's say the asymptote is 1. That might be 1.5, 1.4, 1.3, 1.2, 1.1, 1.0.9, 1.0.8, all the way down to 1.000000001. You know what I mean? So it's never gonna touch it, but it's gonna get very, 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 very close. So what this means for us is that we need to find the asymptote to give us a starting point for our graph. Okay, so if the asymptote is at 1, like it is here, you're going to draw the line along. So it's pretty much touching 1, but not quite. And then it starts to rise, hits the y-intercept, and goes up. So you will find these 2 points and the asymptote when you graph. Finding the asymptote is pretty easy. It's just k. Okay, so if you have a function like these ones back here, where there is no k, it's 0, 0, 3. The asymptotes actually give us help when finding the domain and range of exponential functions as well. So if you remember, domain is all the values for x. This function goes infinitely off in that direction, and it goes infinitely off in that direction, which means that domain's going to go from negative infinity to infinity. Okay, or we can do that all real numbers. The range, however, goes from the asymptote up, or if it's a negative function, from the asymptote down. Okay, so the range for this one, if we're saying that that's 1, would be 1, doesn't include 1, so it's got a round bracket, to infinity. Okay, so just have a think about that when you're graphing it, what the domain and the range are going to look like. So we're going to bring all that information together, and we're actually going to start graphing the exponentials. Now these I find are almost a bit easier than cubics and quadratics because you don't have to find the x-intercepts, and everything else is pretty good to find. So we're going to go through 3 examples. We're going to find the y-intercept, the asymptote, and one other point. So this is what you always do when you graph, these 3 things, and then bring them together for the graph. So our first one here, we're first going to find the y-intercept. So the y-intercept occurs when x equals 0. Therefore, the y-intercept is at 1. Okay, I'm underlining my answers as I go, especially if it asks you for it, to make it really, really clear to other people that this is what the y-intercept is, this is what the asymptote is. Okay, our second one, we've got to find our asymptote. If we go back up for the formula sheet, the asymptote, the horizontal asymptote is at k. Okay, I don't have a k, so that means it's plus 0. So asymptote at 0. Okay, I've got two points. Problem here is it could look like that, or it could look like that, or it could look like that. Okay, so I need one other point to kind of anchor my graph. You can pick any point. You can make x 50, you can make it 10. The quickest one to do is make it 1. Okay, so I'm going to do that. Y equals 10 to the power of 1, which is just 10. So another point is at 110. So I've got my y-intercept at 1, I've got my asymptote at 0, and I've got another point at 110. Didn't do a very good scale there. So my graph is going to run along, it's going to build slightly, it's going to go through 1, and it's going to jump quite steeply up to 10. Okay, I label my points. And my axes, and I'm done. Okay, so you're getting those 3 points, bringing them together in a graph. If you get, say, an asymptote at 0 like that, and a y-intercept at -2, and a point down here, you're going to be going downwards instead. That only happens when one of these numbers out the front is negative. Okay, so just be aware it can be upside down. It doesn't mean it's wrong, but if you get those 3 points, you should be okay to graph any of these exponential functions. Okay, let's try the next one. Okay, so we're going to start with our y-intercept when x equals 0, which gives us 10 to the power of 2 take 0, which is just 2, plus 5. 10 squared is 100 plus 5. My y-intercept is at 105, so it's starting off really high. Okay, underlining that to make that clear. So I've got my y-intercept, now I need my asymptote. So asymptote occurs at k, so you look on your formula sheet, k is 5. Asymptote is at 5. Okay, so we've got 2 things. Now we've got to find one other point, and this is the point that kind of tells us where the graph is going. So we're going to make x equal 1. 10 to the power of 2 take 1 plus 5. So the point is going to be at 1 comma something. So let's see, 2 take 1 is 1, which is 10, plus 5 is 15. Okay, this is where most people will start to freak out. But the trick is, as long as you've got a horizontal asymptote, you're okay. So let's try it. So I've got my x and my y axes. I've got an asymptote at 5. I've got a y-intercept at 105. And I've got another point at 115. Okay, see what I mean? So you are not wrong if you get to here. It's actually just going the other way like this. Okay, and we can see that because up here we've got a negative x, which flips it around like that. It can also at times be flipped down, like I said before, like this, if we've got a negative number out the front. So as long as you show all those 3 points and you've got a horizontal asymptote, as in you don't have a vertical one where the function goes like this, you're okay. If you've got a vertical asymptote, you're looking at a logarithmic graph, and if you've got an exponential function, something's gone wrong. Okay, so we've got a horizontal asymptote, and that's our little graph there. Let's try this last little one. So y-intercepts first. Remember, you get points for these. Even if you can't get the graph, get this paper as you can. So y-intercept when x equals 0. Therefore, f of 0 equals 2 times 5 to the power of 0 over 2. Okay, 5 to the power of 0 over 2, well 0 over 2 is just 0. Anything to the power of 0 is 1, so 2 times 1 is 2. So the y-intercept is at 2. Okay, asymptote, there's no k. So asymptote's at 0. And we need one other point. Now, remember how I said that 1 is normally the easiest? It normally is. In this case, though, because we've got a fraction, if I put 1 there, it's going to be 5 to the power of a half. okay, which we can do, but it's going to be very painful if we don't have a calculator. So we're going to pick the easiest value for x so that we can do it manually. So some easy options would be 2, because 2 divided by 2 would give you 1. 4, so then you just have to square 5. So you want something in there that'll make life easier for you. I'm going to pick 2, I believe in the lazy way of doing things. So we've got f of 2 equals 2 times 5 to the power of 2 over 2, which is just 1. So another point is at 2 comma 10. Okay, so let's graph this. We might go up here and we're going to put our points in. So our y-intercept is at 2. Our asymptote is at 0, so it's along the x-axis. And we've got another point at 2 comma 10. So this one's looking more like the standard function because we've got no negative x's in there. So I'm going to run it along near the asymptote and I'm going to go upwards. Labeling points. Okay, and we've sketched the last one. So they really are, once you get the hang of it, quite a bit simpler than the ones we've been doing. So y-intercepts when x equals 0, asymptote is k, and one other point, use x as 1 whenever it's easy. When it's not easy, use something else. Okay, so that brings together all of our graphing exponentials. It's a little unit, but it takes a little bit of time to get your head around. So make sure you do all the practice questions and have a go at the similar questions on your assignment as well.